Hello my dear learners, welcome back. Today in this video, I would be giving you the basics on how to find and how to represent a complex number in polar form, or how do I represent a complex number using polar representation. Okay, so to start off with polar representation, we will have to know certain basics which we have already done in our lower classes. Okay. So to begin with, let me come up with an example. So if I write this as 2, 3, I have an ordered pair 2, 3. In the place of x, I have 2. In the place of y, I have 3. Now, how do I represent 2, 3 on the Cartesian plane? We all know what is a Cartesian plane. A Cartesian plane is a two-dimensional plane which has x-axis and y-axis, which can be represented on any plane. So obviously 2, 3 can be represented on my Cartesian plane. So Cartesian plane, I will just draw the scale. So 1, 2, 3 for example. I have 1, 2, 3. So x value is 2, y value is equal to 3. So my point will be represented somewhere here. I will call this as 2, 3. This is how I represent 2, 3 on the Cartesian plane. So I think you people have already finished learning this. This is just the basics to come across how to represent a complex number on the plane. So when I come across 2, 3, it is an ordered pair. Ordered pair representing on a plane becomes representing an ordered pair on the Cartesian plane. Okay. So if I have to represent a complex number, then it becomes representing a complex number on the Argand plane. Okay. So there is a difference between Cartesian plane and Argand plane. Okay. So now that we have understood how to represent an ordered pair on the Cartesian plane, let us understand how do I represent a complex number on the Argand plane. So further from there, we will try to understand how do I write the given complex number in polar form, or how do I represent it using polar representation. Okay. So for example, if I have a complex number, z is equal to 2 plus 3i. Okay. Z is equal to 2 plus 3i. Now in my previous example, I had x value and I had y value, correct? So for plotting any 2 points on the plane, we require x-axis and y-axis. But here I have 2 plus 3i. I have a real part and I have an imaginary part. How do I bifurcate the terms so that I represent on the Argand plane? Please pay attention, my dear learners. Here real part is there, no? This real part will be called as x-axis. Understood? This is real part of z, which is nothing but 2. Similarly, 3 is called as imaginary part of z, and this imaginary part of z will be called as y. Understood? So this is how I bifurcate. So therefore, I get x as 2 and y as 3. Now how do I represent these two values on the Argand plane? So when I come to Argand plane, again I will have two axes. Why will I have two axes? Because I have real part of z, imaginary part of z. Again real part of z and imaginary part of z has to be represented on the plane. Okay, and this representation is called as representing it on an Argand plane. Here x-axis is called as real axis. Okay, and y-axis is called as imaginary axis. This is the only difference between Cartesian plane and Argand plane. X-axis is real axis, y-axis is called as my imaginary axis. Now we all know real axis is x, imaginary axis is y. So obviously how will I again plot the points? This again 1, 2, 3, 1, 2, 3. So I have x as 2, y as 3. So the point is somewhere here. So I will write this as 2, 3. When I have to represent it on the plane, representation will be like this. But when I am writing it using a complex form, it will be written in the form of a plus ib. I hope this is understood. So representing on the Argand plane, a complex number will look something like this. And one more very important aspect is, obviously this is called as origin. Origin will be called or will be plotted as 0, 0. Correct? This will be origin. Now, if I call this as point A 2, 3, then I have origin 0, 0. Then this distance OA is nothing but modulus of Z. Okay? And this modulus of Z is also called as R. And this is formed using the formula square root of x square plus y square. Okay? And this formula, how did I come across? I will explain it to you in chapter number 13. Yeah, chapter number 13, that is straight lines. So in that particular chapter, when I start, I will explain it to you. How did I get it as x square plus y square? Basically, I am using distance formula. You people have studied all that in 10th standard also. Basics of distance formula, square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Consider 0, 0 as x1, y1. Consider 2, 3 as x2, y2. Substitute in distance formula, you will get an equation x square plus y square. Since I am considering it as x1, y1 and x2, y2, either you will get it as x1 the whole square plus y1 the whole square, or you will get it as x2 the whole square plus y2 the whole square. Getting it? So now, and yeah, after getting it in the form of x square plus y square, substitute the values of x and y. Okay? So when I substitute the values of x and y, I will get my r value to be equal to 2 square plus 3 square, which is equal to square root of 4 plus 9, which is equal to square root of 13. Here r is equal to square root of 13. This is the first step of representing a complex number in polar form. Okay? Very important aspect is, any complex number given in the form of z is equal to a plus ib, first find out its real term, its imaginary term. After finding real and imaginary term, write it in the form of x and y. Okay? So after I write it in the form of x and y, substitute in the formula modulus of z is equal to r. Correct? Why is this r? Because this is nothing but radius. Okay, this I'll explain it to you in detail. So now, modulus of z is equal to r, and this r is given by square root of x square plus y square. We already know the value of x and y. Substitute back here and you will get the value of r. Okay, so this is the first step. So first step involves finding modulus of the given complex number. After finding modulus of the given complex number, step number 2 is to find out the argument. Here argument is nothing but angle theta. Understood? Now here argument is a real challenging part in finding out polar representation. So what is theta? Theta is obviously an angle. See, you can also see the angle direction, angle direction, right? So angle direction, obviously in anti-clockwise direction, theta is going to be positive. Okay? So this, to have a clarity on why is it positive, why is it negative, that you will come to know in my upcoming videos when I do videos on trigonometry. So once if I finish with complex numbers, we will start with trigonometry. Okay? So theta is nothing but argument. Again, to find out theta, there are two parts. Okay? The first one is to find out alpha. Okay? And after I find out alpha, to compare value of that particular alpha that you have got, in which quadrant it falls. Okay, so that I will teach you with one example. So with that one example, polar representation, which will fetch you a 4-mark problem. I mean a 3-mark to 4-mark problem. 3-mark will be for CBSE, for PU board, and 4-mark will be for CBSE. So in that case, so when I take an example, how do I find out argument? How do I find out alpha? And finally, how do I represent all these whatever I have found out in polar representation will be clear. So I think with this, basics on Cartesian plane, Argand diagram and finding modulus is clear. So in my next video, I will be explaining you how to represent it, I mean the given complex number, using polar representation. Will be done with the help of a complex number in my next video. Please stay tuned. Thank you all.